Okay, question 7. Want to write 1.77 with a recurring decimal, write it as a fraction. Okay, so write it out as the sum of its parts, so 1 whole unit plus 0.7, or you can write it as 7/10, plus 0.07, which would be 7/100, plus 0.007, which would be 7,000, plus 7 over 10,000. It would go on to infinity. So the pattern starts to repeat itself from here onwards. So that will be the sum to infinity part. The 1 stays as it is, so I'll just bring it down. So I use my S of infinity formula for this pattern, where A is the first term. So the sum to infinity is A all over 1 minus R. So that's A all over 1 minus. The common ratio, term 2 divided by term 1, gives you 1/10, or 0.1 as a decimal. You can then tidy that up. Again, don't forget about the whole unit that was here. So it's 1 plus 7/10 divided by, that becomes 9/10. 7/10 divided by 9/10 becomes 7/9, and 1 whole unit plus 7/9 would be 16/9. Part 6, 1.004, and there's a recurring decimal over the 4, so it goes on forever after that. Break it up as the sum of its parts, 1 whole unit plus. The first 0.004 would be 4 over 1,000, okay, or 0.004 as a decimal. The next 4 after that would be 0.0004, or 4 over 10,000. The next one after that would be 0.00004, okay, or 4 over 100,000 if you want to write in fractions, and it goes on forever. So the repeating pattern starts here and it'll go on to infinity. So A is the first term, which is 4 over 1,000, or 0.004. To get your common ratio, term 2 divided by term 1 will give you 0.1, or 1/10 as a fraction. Put down your S of infinity formula, A all over 1 minus R. So it'll be 1 whole unit plus the sum to infinity. A, which was 4 over 1,000, divided by 1 minus 1/10, which was your common ratio. That tidies up to be 4 over 1,000 divided by 9/10, which tidies up to be 4 over 900. Or that would also break down again to 2 all over 450. So 1 plus 2 all over 450 will give you, okay, well this top heavy fraction could be simplified further. Divide above and below by 2. And it becomes 226 all over 225 as a top heavy fraction. Okay, so that's what that recurring decimal can be written as. Question 8, part 1. 1.23 and the recurring decimal is over to 3. So it'll keep going on 3 after that forever. Break it up, 1 whole unit plus 0.2, which is 2/10, plus 0.03, which is 3 over 100, plus 0.003, which is 3 over 1,000, plus the next one will be 0.0003, which is 3 over 10,000. The comma is in the wrong place there. Okay, 10,000. Right, the repeating pattern starts at the 3 over 10,000. Okay, so bring down the 1, bring down the plus 2/10, and then I'm getting the sum to infinity of that series because that would have gone on forever, okay, to infinity. So A is my first term, which was 0.03, or 3 over 100, divided by 1 minus common ratio. Term 2 divided by term 1 in the pattern gives you 1/10, or 0.1 as a decimal. So that's going to be 3 over 100 divided by 9/10, okay, which is what I have here. 3 over 100 divided by 9/10 is 1/30. So now it's going to be 1 plus 2/10 plus 1/30, which breaks down to 37/30 as a top heavy fraction. So that was question 8, part 1. 8, part 4, 9.188, and there's a recurring decimal over the 8, so it's going to continue on 8. Break it up, 9 whole units plus 0.1, which is 1/10, plus 0.08, which is 8 over 100, plus 0.008, which would be 8 over 1,000, and it will keep going on. Okay, so plus ... onto infinity. So the pattern starts to repeat itself here. So that's your first term, that's your second term. Bring down the 9, bring down the 1/10. A is your first term, 8 over 100, or 0.08 as a decimal. Common ratio, term 2 divided by term 1, and you'll get back 0.1, or 1/10 as a ratio. Okay. Tidying that up, 1 minus 1/10 is 9/10, so it's 8 over 100 divided by 9/10, which simplifies to 8 over 90. Or again, that would be 4 all over 450. Or sorry, 4 all over 45, I should say. Then you're adding 9 plus 1 all over 10 plus 8 over 90, which breaks down to this top heavy fraction, and that doesn't simplify any further. And again, you can always use the recurring decimal button on the calculator to type in that and to see, am I right when I get this value back? So just to show you, it would be 9.1. Then I'll press my recurring decimal button, which is the box with the little dot over it. Okay, and I'll put in my 8 equals 827 over 90. And that's exactly what I just got when I did it by hand. 9 part 4, 3.454545. Okay, so write it out as the sum of its parts even. 3 whole units plus. The first pattern is the 45, so 0.45 or 45 over 100. The next 45 is 0.0045 or 45 over 10,000. The next 45 would be 0.00045 or 45 all over a million. That should be, the commas are in the wrong place. Okay, so the repeating pattern starts here and that will go on to infinity. So 3 whole units plus, this is my sum to infinity formula. A is 0.45 all over 1 minus the common ratio. Term 2 divided by term 1 and you'll get back 0.01 as a decimal or 1 over 100 as a fraction. Tidying that up, 1 take away 1 over 100 is 99 over 100. Fraction divided by fraction, you'll end up getting 45 over 99. So 3 whole units plus 45 over 99, 342 over 99, which breaks down to 38 over 11. So 3.45 recurring decimals breaks down to 38 elevenths as a top of a fraction. Again, I can check on the calculator. Okay, getting back the same fraction. Part 6 of question 9, 2.960, and the recurring decimal is over the 6 and the 0, so it would look like that if I was to write it out. And it'll keep going, 60, 60, 60, 60. Write it out as the sum of its parts, 2 whole units plus 9/10, which would be 0.9. Then the first 60 would be 0.060, which is 60 over 1,000. The next 60 that would occur here would be 0.00060, which is 60 over 10,000 and so on. That'll go on to infinity. So there's your repeating pattern. A is your first term, common ratio, term 2 divided by term 1, and you'll get back 1 over 100 or 0.01 as a decimal. Sub that into your S of infinity formula, so it'll be 2 whole units plus 9/10 plus, this tidies up eventually to be 6 over 99, which would break down as well. It'll break down to 2 all over 33. So then you'll be adding 2 plus 9/10 plus 2 all over 33, and you'll get back this fraction, which tidies up to be 977 all over 332. And again, I can check if that's correct by subbing it into the calculator, and I get back the recurring decimal that I started with. Or you could put in the recurring decimal and see do you get back the fraction. Okay, part 9, 4.3506, and the recurring decimal is on the 5 and on the 6, which means after the 6 it's going to be 506, again 506, and it'll keep going on in that fashion. Break it up as the sum of its parts, 4 whole units, then 0.3. Now I've just written that as 4.3 on its own, and then I start with the pattern part, but it's the same as writing it as 4 plus 0.3 plus each of these. Okay, so this is the part that is your pattern. A is the first term, common ratio, term 2 divided by term 1, and I'll get out 1 over 1,000, which is 0.001 as a decimal. So that equals the 4.3, or the 4 plus 3/10. Okay, I put down my S of infinity formula, which is A all over 1 minus R. I just leave them in fraction format, but you can write the decimal equivalent, it makes no difference. And again, it's 4 plus 0.3 or 4 plus 3/10, which I've just written as 4.3. Okay, that's my S of infinity formula, subbed in, tidied up, break it down. Eventually you'll get out 4.3 plus 506 over 9,990, which would simplify as a fraction anyway. And you'll eventually get out this fraction, 43,463 divided by 9,990, which doesn't simplify. Okay. Now, when you're checking that one on the calculator, it actually won't, because it's actually such a long repeating pattern, it actually won't give you back the fraction equivalent, so you actually won't be able to see if you're right or wrong on that one. What you could do is you could plug your fraction into the calculator and see what would that give me back as a decimal, and you'll see it'll give you back this, but they'll actually end it up, they'll make it finite, as in it'll terminate, and it'll be 4.35065, and there'll be a 1 at the end of it. Okay, so it won't look exactly like what we have, but that is still the correct answer.